let's talk about number 1 from the problems I left you with. We were to graph f of x equals x squared minus 4x minus 7 using the properties, so I'm going to go through this pretty quick. A equals 1, so it opens up. The axis of symmetry, x equals negative 4 over 2 times 1, which works out to be 4 over 2, which is 2. The axis of symmetry is the vertical line at x equals 2. The vertex, we know the x-coordinate will be 2. We just have to find the y-coordinate. We're going to get that by plugging into the function. And that turns out to be negative 11. So the vertex is the point to negative 11. Okay, still going. Property number 4, find the y-intercept. We'll think of it as y equals, plug in 0 for x. We got negative 7. So the y-intercept is 0, negative 7. And to find the x-intercepts, something a little different happened here. So I'm glad we are doing this problem. Here's what I've got. So, we'll begin by saying y equals 0, and then use the quadratic formula. And everything seems to be okay when we plug in. But then it turns out that we don't get a perfect square under the square root. When you do that, you get 44. So it boils down to 4 plus or minus square root 44 over 2. So at that point, I just went ahead and wrote the two separate equations, like so. Now, normally, we would reduce these radicals. However, our goal here is to graph. So I have no idea what that number is, right? So I'm just going to use my calculator and round the x coordinates to 1 decimal place. So when I did this first one, that whole thing, I got 5.3 when I rounded. And when I did the second one, I got negative 1.3. So for graphing purposes, this will be plenty accurate. So I'm going to graph 5.30 and negative 1.30. So if you got stuck at this point, here's a way around it. You can just go ahead and round those off, each one, and this is what we'll end up graphing on the page. So here's what I plotted. Again, going through this pretty quick. So I began by plotting the axis of symmetry. Then I plotted my vertex there on the axis of symmetry at negative 11, to negative 11. We can plot our y-intercept, and we can plot our x-intercepts, right? Counting out 5, and then a little bit more for 5.3. And this way, negative 1.3 is about right there. 1 decimal place is really all you need, right, for graphing. And of course, it turns out we can graph one more point if we use the mirror image of our y-intercept. And we can tell, yep, this is going to point upwards. And so I got to connect the dots to finish the graph, of course. Don't forget to connect the dots. Put an arrow right there. And of course, keep the parabola nice and round. There's your graph. Okay, let's get to number 2. Here's what we were given. So let's just talk about what they're even saying and what's even happening with this problem. And then we're going to be able to answer both parts of the question like immediately. So here's the path of I think it was a stone that got thrown. Okay, so when you throw an object, maybe you know, it takes a nice curved arc through the air. It's going to look a little something like this. So maybe the person is standing here, right? And they throw the stone and it goes up and it pauses for a moment at the top and then it starts to fall and it hits the ground. The question, both parts of the question, parts A and B, were getting at the maximum height. Well, the maximum height is the very top of that arc, right? And isn't that the vertex of our parabola? It takes this nice parabolic shape as it flies through the air. Okay, let's go ahead and find the vertex for our equation there. So if you remember the x-coordinate, although here it's t, the t-coordinate is negative b over 2a. So I've got negative 160 over 2 times negative 16, which works out to be 5. Okay, so there's the x-coordinate, if you will, the t-coordinate. So I'm going to put that 5 to find the y-coordinate. I'm going to put that 5 back into the function. Putting 5 in. And I know I'm going kind of quickly. This works out to be 420. So the vertex for that graph is at 420. It's actually very, very tall. This guy's got quite an arm on him to throw it that high up. Okay, so now that we know where the vertex is, let's take a look at what they asked us. Part A was, at what time does it reach its maximum height? And it turns out that's just the x-coordinate of the vertex. That's the t, right? That's the t and that's the h. The time to reach the maximum height, 5 seconds. Now, if you think of an object flying through the air, if it took 5 seconds just to get to the very top, that's really going high up into the air. But that's okay. Then part B was, what is the maximum height? Well, that's the h, 420, and here it was feet. So there's the answer to number 2. Hope you did well with both of those. Okay, hey, homework for both of these sections is up. Please bring your questions to Monday's Zoom session. See you there.